Yesterday was all about leading you up to today, understanding what a binomial square is, how to come up with it, what the pattern all is. Now I'm going to show you how to solve some equations using completing the square. Okay, that's all what yesterday was about, was getting you ready for today. Okay, now I'm going to show you the steps first. Okay, the reality is completing the square is just solving equations using the square root property. We did that yesterday. We solved a whole bunch of equations using the square root property. Now today, yesterday the problems were all set up for that, right? The left-hand side was already a binomial square. We could convert it to that form, and then we would square root both sides, and we were good to go. Today's not going to be like that. The left-hand side is not going to be a binomial square to begin with most of the time. And we're going to force it to happen. And that's what the second part of our homework was about, when we force those expressions into becoming binomial squares. So that's where we're practicing it. We're going to do that again today. Okay, so here are steps that we have to take. They're similar to what we did in that second group of equations yesterday, or expressions. Okay, first thing, we got to get the constant term on the opposite side of the x squared and x terms. So where we've been doing problems before, we always had the one side 0. This is going to be an exception. We're actually going to get the constants, the non-variable terms, on the other side, away from the x squared and x terms. That's new. We haven't usually done that. Most of the time we've moved everything to the one side and made the other side 0. This is a little different this time. Okay, so that's the first term. We're just going to isolate the squared term and the linear term and put the constant, the number, on the other side. The other thing we have to do after we do that is we need that coefficient on the x squared to be a 1. In all the problems we did yesterday, that was set up for us. The x squared term always had a 1 coefficient. There was no number in front of it. If there is a coefficient on the x squared that isn't 1, then we have to make it a 1. And the way that we do that is we divide each term by whatever that number is. So if it was 3x squared, we divide each term by 3. If it was 5x squared, we'd have to divide each term by 5. Ultimately, in order to solve by completing the square, that x squared term has to have a coefficient of 1. Okay, so that's the next thing. All right. After we get it into that form, if it's not already that way, now it's just like that second group of problems that we did yesterday where we found c. Okay, we took that middle term divided by 2 and squared it. Okay, and that's what we're going to do here now. So we've already done that a little bit. Divide the x term's coefficient by 2 and square it. Here's where it gets a little bit different. Now here's the difference. Yesterday we were looking for that value c, and that's what we would have gotten out of the step 3. Now we don't have an expression, we actually have an equation. So here's where it gets a little bit different. Okay, you're going to add that, whatever that divide by 2 and square it number is, we're going to add it to both sides of the equation. Because what we'll have done, and most of the time it'll be the left side, we'll have now converted the left side into a binomial square, but I can't just add to one side of an equation, right? You've got whatever you do to one side, you got to do the other side. So that's why we also add it to the other side, to keep that equation balanced. Okay. What we've accomplished in these first 4 steps is we've changed the left-hand side and forced it to be a binomial square. All right, so we're going to then solve that equation using the square root property. So now we've turned, using those first 4 steps, we've turned it into a problem from the first group that you did yesterday. All right. So instead of the left-hand side being set up as a binomial square, now you're going to force that to happen, and then once you've got it into that form, then you're going to solve it the same way that we did. Okay? Question? Questions so far? So not a ton new here, a couple wrinkles, but a lot of it stuff we did yesterday. We're going to apply it into a little bit of a different forum. All right, so let's look at an example and we'll talk through how to do this, okay? So here's my first example. X squared plus 10x plus 24 equals 0. I can tell you right away that this is not a binomial square because 24 is not a perfect square. Okay? You can factor it, which is why I used this problem so that our numbers turn out nice in the end, because I can look at this and you should be able to figure out how to factor and what the solutions are. And you don't have to do it, you don't have to write it out, but the reason that I use this type of equation is so that when you see the final answer, that when we work through completing the square, we can see how to arrive at that answer in a different way. Right? Most of the problems, to be perfectly honest, are not going to be that nice. So, first step is to get the x squared and the x term on the one side by itself and move the 24 to the other side. So of course it ends up looking like this. Now notice I left some space here, because if you remember, part of our process is dividing by 2 and squaring it and adding that to both sides. Well, I got room over here to add something. I needed to create a little room so that I can add something in here. Okay. So what number am I going to divide by 2 and square? 10. Okay. So I'm going to take, and I just kind of do it off to the side. 10 divided by 2 squared is 25. So I'm going to take that 25 and I'm going to add it to both sides. Okay. And what I'm doing now is I'm forcing this left-hand side to become a binomial square. Okay? So, go ahead and rewrite this as a binomial square and simplify the right-hand side. So, what is this as a binomial square?
X minus 5 squared.
X plus 5.
X plus 5.
And then what's the right-hand side? 1. Okay. So when I rewrite it as a binomial square, I get x plus 5 squared, quantity x plus 5 squared equals 1. So now it's set up to use the square root property to solve. So go ahead and finish it. If you didn't already, go ahead and finish it. So I'm going to take the square root of both sides, which means I also have to take the plus or minus on the right side. Okay? The square root and squaring cancel. What is the square root of 1?
1.
Okay, so I have x plus 5 equals plus or minus 5. I subtract the 5. Okay, and now I split them. Okay, and negative 5 plus 1 and negative 5 minus 1, negative 4 and negative 6. How many had that?
I did.
Okay, very good. And like we said at the beginning, yes, this could have been factored x plus 4 times x plus 6, and I could have jumped to my solutions that way. I used this problem just to illustrate that with the numbers that are nice and easy. Okay? So, of course, the next example is not going to be so nice and easy. All right, and there's going to be some more complications involved, which means there's going to be a bunch of what?
Talking.
Fractions, correct. Okay, so let's look at the next example. Okay, 3x squared plus 10x minus 8 equals 0. First move. What do I got to do? Move the 8 to the other side, add 8 to both sides. Again, leave some space in here because you're going to have to add something in. What's my issue now?
It's still 25.
You're gonna add 16.
I have a 3 in front of the x squared.
Oh.
That's bad.
Oh.
Okay, I have to get rid of this 3. How am I going to get rid of it? Okay, so divide everything by 3, which means I'm going to have a bunch of nasty fractions. And they're not going to go away. Okay? And this is what completing the square is often about. This is the thing. You're going to see this a lot with completing the square. That first one was sort of a nice, easy one. Most of the time it's going to be something more like this. Okay? So, again, we're going to force this left-hand side to become a binomial square. We follow the same steps. What do I do?
10 over 3 squared.
Not quite.
What?
10 over 3 divided by 2. Okay? Okay, 10 over 3 divided by 2 and then square it.
Hold on.
Okay, so go ahead and do that and figure out what the value is. It is 25 over 9.
But then you have to make the others.
Hold on. So 10 thirds divided by 2 is the same thing as 10 thirds times 1/2. That is 5 thirds. I have to take 5 thirds and square it, so square the top, square the bottom. That's where 25/9 comes from. Now, here's what I do with that. I have to add it to both sides of the equation.
Can you simplify it?
We're gonna
All
eventually.
terms?
Yeah, I mean 25/9 is simplified.
Yeah. No.
Okay, now, so I added that 25/9 to both sides, which means I have forced this side into becoming a binomial square. Okay, so the square root of 25/9, the number I got before I squared. So that's the other thing. When I had 10 thirds divided by 2, that number is what's going to go in the parentheses down here, which we already said was 5 thirds. Or if you don't remember that, you can just take the square root of this again. Square root of 25 is 5, square root of 9 is 3. Okay, so my binomial is x plus 5 thirds squared. And then you have to be able to simplify 8 thirds plus 25/9,
49.
okay, which is 24/9, which is 49/9. Okay, so that gets me. Alright, so when I've converted it into binomial squared form on the left, I've simplified the fraction on the right, and we're going to be in a position to solve using the square root property. Now you can solve this like we did yesterday, and we did on the problem before. I'm going to take the square root of both sides. Okay, right, plus or minus, the square root and the squaring cancel,
7 thirds.
and what is the square root of 49/9?
7 thirds.
7 thirds. So here's what I have.
Yeah.
X plus 5 thirds equals plus or minus 7 thirds. Subtract 5 thirds from both sides. That's going to look like this, and now I've split them, okay? So I have my plus, I have my minus, I have common denominator, so it's just a matter of combining the top. And your final answer, 2 thirds and -4. How many had those? So let's recap what we've done today. This is the conclusion of completing the square. So the first set of problems that we did yesterday, it was solving by square root property. Half of what you do today is that. The second group of problems that we did yesterday, when we found that last value that made it into a binomial square, the first part of what we do is that. So now we're combining it together and solving some equations that are kind of tricky. Now, here's the thing. We're going to get into this more when we get into 4-7, like I mentioned, that putting quadratics into vertex form, that requires us to know how to do this. You're going to have a quiz next week over this, so you're going to have to know how to complete the square. And you're also going to know need to know how to work with complex numbers, okay? And then after that we'll get into quadratic formula, discriminant, and vertex form. Okay? Questions?